Okay, this is part 3 of our video on graphing exponential functions. We're going to look at having a base e, and so let's talk about that for a second. So the irrational number e, approximately about 2.72, is called the natural base. The function f of x equals e to the power of x is called the natural exponential function. And so here's that number out to a couple more decimal places. And here is actually how this is derived. And so if you take the value of 1 plus 1 over n raised to the power of n, as n goes to infinity, the larger that n value gets, the closer that value is going to get to that e right there. And this is a value that's used quite a bit in financial math. And so we'll see a couple word problems with it in a little bit in the next video. But for now, we're just going to kind of look at graphing it. And so it's not really much different than what we've already been doing, except that you are going to have these decimals that we kind of have to work with. But what we're going to do, and I kind of alluded to this in the previous video about transformations, we're pretty much probably just going to use transformations to graph these. And so what we're going to do is we're going to take these 3 key points right here, and we'll just go ahead and move them around using transformations and then graph our function here. And so once again, yeah, we will have horizontal asymptote and so on. So here are the rules for our transformations, which I actually already kind of went over in the previous video somewhat, but here's an actual list of them. And so we have our vertical transformation, which that's pretty simple. If you add or subtract, you're going to go up or down. Then you have your horizontal transformation, which is where you add or subtract directly to the variable x. And it actually does the opposite of what you kind of would think, because when you add to x, you actually shift left. And when you subtract, you actually shift to the right. So if you remember transformations from Unit 2, it kind of follows the same rule where the horizontal transformation kind of behaves in a way you would think would be the opposite. And then we have our reflections. And so if you have the negative directly in front of your base right there, that's going to cause you to reflect about the x-axis. And if the negative is directly with the x value, then you're going to reflect about the y-axis. And we saw a couple like that in the previous video. Okay, so what we're going to do now is we're going to look at this, and you could use a calculator if you want and make a table. But what I see here is that my transformation is I'm going to go to the right. We're going to go right 2. So those original points were about right here, here, and 2.72 about right, maybe a little higher up right there. And then I also do have my horizontal asymptote is going to be at y equals 0. Now, what my transformation is going to do is that's going to shift all these points right here are actually going to move to the right um, 2 spots. And so that's what I'm going to do here. I'm going to take that and move that to, oops, let's see. So we started out right here, and we're going to go 1, 2 to the right, and then I need to grab that other point also and move that one to the right 2. Right there. And so that's what's going to happen here. And then we'll go ahead and add my horizontal asymptote right here. And then we'll just go ahead and graph this going like so. And there we go. And so let me go ahead and label my asymptote right here, y equals 0. And my range on this one is going to be from 0 up to infinity. Okay. And then that's it. So transformations actually can make your life a little easier if you use that. The thing about the previous ones we were doing was we were using different bases. We would have base 2 and base 5 and base 1/3. And so that's a little different with transformations. I mean, you can still use them, but each one looked a little different. What we're working with is they're all going to pretty much look like what we have up here as far as the spacing of the points, right? And so that's kind of what I'm doing here. So on this particular one, once again, I'm going to go ahead and put those original points. So you'd have one here, here, and about right here. And this transformation is going to cause us to go down 3. So my horizontal asymptote shifts down 3, so it's at y equals -3 is where that's going to be at. So let's go ahead and put that on here. So let's see, that's at y equals -3. And then I'm going to take those 3 points that's from the original function, and we're going to shift them down 3. So 1, 2, 3. I have to grab that other one. Let's see, down. Well, let's see. Start right here. Down 1, 2, 3. So it's going to be about right there. And then we'll go ahead and graph this with the smooth curve. And oops, probably going a little too fast. Let's see. There we go. And coming along my guardrail. And there we go. And my range on this one is going to be from -3 up to infinity. Okay, I just have 2 more of these to look at, and then we'll take a look at the word problems, which I know a lot of times students are hesitant with word problems, but they're pretty fun. They're financial problems, and so I think you might like that. Okay, so looking at this one, I have 2 transformations actually taking place here. You always want to do your left and right first. So this is actually going to be left 2, and then we're going to go down 4. Down 4. And so that down 4 is going to put my horizontal asymptote at y equals -4. So we'll go ahead and put that on my graph right there. So y equals -4 right there. Then once again, I'm going to put those first couple points on here. So we have one here, here, and here. And so my transformation is left 2 down 4. Left 2 down 4. So let's see, left 1, 2, down 1, 2, 3, 4. So they end up right there, and I got to take this point and do the same thing. Left 1, 2, and down 4. 1, 2, 3, 4. So about right there. And so we'll go ahead and graph that. So let's see. There we go. And let's see so we can see those points a little better. And let's see, my range is going to be from -4 up to infinity. Okay, and then let's see, part D. Let's see what we got going on here. Um, so I do have a reflection right here. And so that's with the X. So I'm actually going to reflect about the Y-axis. So let's see, reflect about the Y-axis. Okay. And so, and then I'm also going to go up 2. So I have to reflect across the Y-axis, flip across, and then um, go up 2 units. So let's put those original points on here. So let's see, I have one kind of down here, and then I had one right here, and then right, let's see, 2.72, about right there. Okay, so I'm gonna have to reflect about the y-axis in this case. So I'm gonna reflect to the other side right here, and then I have to go up 2 spots. So I'm gonna go up 1, 2. I actually am getting pretty close to that other point right there, but that's where I'm gonna go. Maybe I should color code this a little bit. So that original point was about right here, and now I'm right here. Then my next point, I reflect about the y-axis while I'm on the line of reflection, so nothing happens there. And then I go up 2 spots, so that would put me there. So I was originally right here, and I ended up right there. Okay. And then my last point, I reflect about the y-axis. So I'm going to go to the other side of the y-axis right here, and then I have to go up 1, 2 spots. So I end up right there. And I'm going to color code that a little bit too. Let's see. Let's do, because I haven't done blue yet. So we started out about right here or so, and I ended up about right there. Um, oh yeah, since I shifted up 2 spots, my horizontal asymptote's going to be at y=2. So let me get that going across right here at y=2. And so here are my 3 new points. So see, it had that reflection. So now it's decaying, right? It's a decreasing function now. It's going down from left to right. So I'm going to go down and then go along my guardrail. And there we go. And then the last thing is my range, which I at the bottom I'm approaching 2, and at the top I go up indefinitely, so infinity. Okay, so that is graphing exponential functions, and so next we'll kind of look at a couple application problems that involve these. I promise they're nothing too difficult. They're actually kind of fun because it deals with financial issues.